Hello everyone, welcome to Mayu Programming Club. Today we will be solving another daily Leetcode challenge, and the challenge name is remove duplicates in letters. So you are given a string S and you have to remove duplicate letters so that every letter appear exactly once and only once. So for example, in this string, B is repeated twice and C is also repeated twice, and in the resultant string all the characters are appearing only once. So also it is further mentioned that if there are multiple such answers, you have to return the smallest lexicographical order possible among such results. So for let's consider for this particular string. In this particular string, you are having two options. Either you could have deleted, let me mark the indices 1, 2, 3, and 4. Either you could have deleted this 0th index B, or you could have not deleted this one, and instead of that this one would have been deleted. So your resultant string, let's say in C, let's say you deleted this, your resultant string will become BCA, which is not the lexicographically smallest possible. So you can do better than that. So how you will be doing finding the lexicographically smallest one? For that, what we will do is, let's say we will use a stack and another list visited, list or say array, whichever uh, you are comfortable with. It depends upon language to language. Here in C++ we will be using vector. So what we will do is, this array will show the visited uh, characters that have been used or say visited, that have been included in final answer, or say string. Now this stack will represent the final string that you will be forming in reverse order. Instead of storing the character, what we will do is, in both of these data structures, stack and this visited array, instead of character, we will store the relative difference of character with small a. So it will be, for example, for B it will be 1, for let's say A it will be 0, for let's say C it will be 2, so on, and from 0 to 25 your difference will be ranging from 0 to 25. So in total 26 values will be required to represent these differences. Let's call this character differences, and the whole stack will be called character difference stack. And let's begin. Now what we will do is, we will iterate the string from left to right. Initially you will push B in the stack since it it's empty as of now. Now B will not be pushed. Its relative difference with small letter a will be pushed, because in the constraints it's mentioned that lower English letters will only be present in the string, and the order of the string will the length of the string will be of order 10 raised to power 4. So what we will do is we will push B. Now B will be visited. Also, before proceeding further, let's mark the indices. They will be required. And another data structure I would like to introduce, which will be used, is a vector, or say array, storing the last index of every character. So for B, its last index of occurrence is 3. For C, its last index of occurrence is 4. For A, last index on the and the only index is 2. So this is how your values will be stored. So for A, B and C, A2, B3 and C will be 4. So what you will do is, let's say now you will check if the character that you are going to push on the stack is greater than the top of the stack. Yeah, it is the case that the character we are going to push on the stack is greater than the top of the stack, so we'll push the character and we will move our pointer to the next character. Let's say this one. Okay, now when we move to this character, we will see uh, that C is greater than A, so the top of the stack is greater than the current character that is we are considering for pushing on the stack. So what we will do is, as long as we can adjust this C somewhere else, what I mean by adjusting is that the last index that at which C is occurring is greater than the index of current character. Last index at which C will occur is 4. So we can leave this C and pick its last occurrence, which is beyond the current index. This is your current index. So it will help us to greedily build the smallest, lexicographically smallest string, because A is smaller than C, so we can place it before C, provided C is having a occurrence which is at an index greater than the current index. The current index is 2, so C is also occurring at this place, so we will remove this. Similarly, we will do for B. So B is also greater than A, and B's last occurrence is 3. As of now, B's 0th occurrence is pushed on the stack. So what we will do is, so C will be removed from the visited array. C is no longer part of the string. So also as we see, B is greater than A and its last occurrence is greater than the current index, which is 2. So we will remove it from the stack, and subsequently we will remove it from the visited array also. So these are not visited as of now, only A will be pushed. So it is visited as of now. So B is greater than A, so it will be pushed. Now v is greater than c is greater than b, so it will be pushed. Now let's say further there are some other words also, b, c, a. These will not be pushed. Why? Because visited array is already containing them. Only one occurrence of each character is allowed, and we have already pushed, and we have built the smallest possible string which is having only single occurrence of a character. So it will be in reverse order ABC. I hope you are able to understand. So we will try to take the smallest, let me quickly change the slide. We will try to, just a minute. Yeah, we will try to take smaller characters towards leftmost possible place. Now let's consider a condition that this C character was not there. I know it's a little messy. Oh, let's say this is not here. So you could not change this C. Because it is not having any other occurrence, you have to put it here itself. So you cannot pop the values of C. So this is the case in which a character is cannot be adjusted. So this is the logic of the problem, and the runtime complexity will be O of n, where n is the size of the given string, and the space complexity will be also order of n, where n is the size of the string. It will be required for your stack and those two vectors or arrays. So let's have a look at the implementation. Approach will be more clear to you in the implementation part. In this particular array, or say vector, we will store the last index of occurrence of every character and one thing to be noticed is it is to be noted that reduce the size of the arrays required to put characters. We are taking relative difference of each character with small a. As our index in last index array and visited array, both of these. So this last index will store the last index of every character, and last indices will be used to see if we can adjust a greater character at the end. Last indices will be used when a smaller character appears after a greater character, and we have to check if we can adjust those larger characters at a index beyond the index of smaller character. So this is the whole logic of the problem. Logic of the solution, or say intuition, to build the smallest character possible. This one is the whole intuition or logic. So after storing the last index, this is the relative difference of the character with a that I am mentioning here, or you can move it to here. Okay, then visited array will be used to avoid duplicates in the resultant string, and rest is pretty much the same, that the simulation that I have demonstrated you for this particular string. So if you encounter a empty stack, or say a non-empty stack with characters larger than the current character, and those larger characters can be adjusted after the current index, then keep popping the values, keep popping those characters from the stack, and this is how you will be building your final resultant string, and this is how you will be building your resultant string. So that's pretty much it, and at last you will reverse the string before returning it, since in stack it will be in upside down manner. At last you will return the string as reversed after reversing it. Let's try to submit it once. As you can see, it's getting accepted. So if you are still having any doubts, please feel free to ask them in the comment section. Code will be available in C++ and Java both. So thank you for watching. Thanks.